Dear students, in today's session we will discuss how we will solve an LPP using graphical method, and in this particular problem you will have more than two constraints. Okay, in the last problem when we discussed about the minimization case, we discussed about two constraints and how we will solve that minimization problem using two constraints. Now here you can see there are more than two constraints. Here to be precise, there are 5 constraints. 1 2 3 4 5. So there are 5 constraints, and using these constraints how we will solve a LPP using graphical method, that is what we are going to discuss today. So the procedure is all the same, just like how we had done before. We will have to equate this. Put A is equal to 0, get the value of B. Put B is equal to 0, get the value of A. And it's all the same. The only thing is, when there are more than two constraints, then the point of convergence or the point of intersection will change. So we will have to find out a common point wherein you get the feasible solution. Okay, so we will discuss this. Okay, here the question is, solve the following LPP using graphical method. Minimize z equal to 3a plus 5b subject to the following constraint, that is minus 3a plus 4b less than or equal to 12, minus 2a plus 1b less than or equal to 2, 2a minus 3b greater than or equal to 12, 1a plus 0b less than or equal to 4, 0a plus 1b greater than or equal to 2, a comma b greater than or equal to 0. So here there are 5 constraints given here. Okay, and again, if you look at the inequalities, you can see 1, 2, 3 inequalities are less than or equal to, and 2 inequalities are greater than or equal to. Okay, so it is all the same. First you need to consider each constraint separately and find the points and then plot it in the graph. Okay, now I consider the first constraint, that is minus 3a plus 4b less than or equal to 12. I equate it to 12. Put a is equal to 0, you will get the value of b. b is equal to 12 divided by 4, 3. When you put b is equal to 0, you get a is equal to 12 divided by minus 3, that is minus 4. So you have 2 points. A, when a is 0, b is 3, and when b is 0, a is minus 4. So the 2 points are 0, 3 and minus 4, 0. So now the thing is, we need to plot it in a graph. Okay, so now we will plot it in the graph. Now you can see that there is a negative value. So since there is a negative value, you should have 4 quadrants for the graph. Okay, so here x-axis will contain the value of a and y-axis will contain the value of b. So here you have to give provision for negative values as well. So this will contain minus a and this will contain minus b. Okay, so the first point is, so we will plot. So the first point is 0, 3. A is equal to 0 and b is equal to 3. That means the point is here. That is 0, 3. Then you have minus 4, 0. A is equal to minus 4 and b is equal to 0. Minus 4, 0. So these are the 2 points. Now you have to join these 2 points. Okay, so I join these 2 points. So this is my first constraint. Okay, I'm joining these 2 points and I get the first constraint. Now look at the second constraint. Minus 2a plus 1b is less than or equal to 2. Okay, minus 2a plus 1b is equal to 2. A is equal to 0, b's value will be 2, and when b is equal to 0, you will get a's value as minus 1. So again you have 2 points, 0, 2 and minus 1, 0. A is 0. 0, 2. So that means that point is here. That is 0, 2. Okay. Then we have minus 1, 0. Sorry. So this is minus 1, 0. Minus 1, 0. This is the second point. Okay. So you will be joining these 2 points. So this is your second constraint. So you have the first constraint and you have the second constraint. Now we will go with the third constraint. The third constraint is 2a minus 3b is equal to 12. Okay, when a is equal to 0, you get b is minus 4, and when b is equal to 0, you get a as 6. So you have 2 points, 0 minus 4. So 0 minus 4. 0 minus 4, that is this one. This is 0, minus 4. And then you have another point, that is 6, 0. A is equal to 6, then the other one is 0. This one is the next point. That is 6, 0. So you will be joining these 2 points. Okay, so when you join these 2 points, you will get the third constraint. Okay, now you have the fourth constraint. So what is the fourth constraint? According to the question, the fourth constraint is 1a plus 0b is less than or equal to 4. So we can equate it as 4. Now if I put a is equal to 0, what will be b? B will be 4 divided by 0, and we know that anything divided by 0 is not defined. It is not defined, so you cannot go for this. Then when you put b is equal to 0, it's already 0, b is equal to 0, then a will be 4. So you have your value like this, a and b. When a is 0, then b is not defined, and b is 0, then a will be 4. So that means you can plot only one, that is here you can have 4 0, 4 0, that is a is 4 and this is 0. This is the point. So this shows that we cannot converge it with another point because the other one is not defined. So what you can do is you can draw a parallel line to that of the y-axis. Okay, so you have a line parallel to y-axis because this point is not defined. Okay, when a is equal to 0, b is not defined. So this is a line parallel to the y-axis. That will be the fourth constraint. Okay, so this is the fourth constraint. This is our fourth constraint. Then the next is the fifth constraint. Fifth constraint is 0a plus 1b is 0a plus 1b is greater than or equal to 2. So I can put equal to 2. So that means when a is equal to 0, b will be 2. But when b is equal to 0, a is equal to 2 divided by 0, which is again not defined. This is the fifth constraint. Okay, so that means again you have a similar case wherein you have a and b. When a is equal to 0, b is equal to 2, but when b is equal to 0, a is not defined. Therefore that shows that this is 0 2. There is a point 0 2, that is this particular point, that is 0 2, and you can draw a line parallel to the x-axis. Similar case is that of the fourth constraint. Okay, so you have a case. This is the fifth one. Okay, now almost all the constraints are over. We have plotted all the points and we have drawn all the constraints. Now look at this particular graph. Does it make any sense? That means here no point, no line is meeting the other one. That means it shows that we don't have a proper feasible solution here. So what we can do, we can try extending the lines. Okay, now I will try extending the line so that it touches the other one. So here this is the first constraint. So if I extend this line further, so when you are extending you have to put dotted lines. Okay, so that it touches this particular fourth constraint, that is the line parallel to the y-axis. So it is touching at this particular point. Again I have another constraint, that is the second constraint. Again I am trying to extend it so that it touches the first constraint as well as the fourth constraint. So I am again extending this line using dotted lines. So this is also touching somewhere. Okay, again there is one more. Yeah, this is already touching this line, so need not extend it. Yeah, you can extend it further because it can touch the fifth line also. So you can extend it till it reaches the fifth constraint. Okay, so now I have extended all these constraints, all these straight lines. Now go back to the question. Okay, here the first constraint is minus 3a plus 4b less than or equal to 12. So minus 3a plus 4b less than or equal to 12. So this is our first constraint. This is the line representing the first constraint. So it is telling that it is less than or equal to 12. That means the feasible region will be somewhere here. That means downwards. It is not going upwards. It is less than or equal to, it is coming down. Okay, so feasible region will be below this particular first line. Okay, then the second line, what does the second constraint say? Minus 2a plus 1b less than or equal to 2. So this is the second constraint. Again that is also less than or equal to. That means the feasible region is below this particular second line also. So this is also coming this side. Then look at the third constraint. 2a minus 3b greater than or equal to 12. So this is the third constraint, that is this line. This is greater than or equal to. Greater than or equal to means again it is going this way. That means above this particular line. It is not below. This is above this particular line. Okay. Then the fourth constraint, 1a plus 0b less than or equal to 4. That is this line. The line parallel to y-axis. Again it is telling that it is below, because again it is less than or equal to. So again this is the feasible region is below this particular line. Then the last constraint, 0a plus 1b greater than or equal to 2. That means the line parallel to this. So it is telling that greater than or equal to. That means it says that the feasible region is above this particular line. So what does this mean? This means that the common point which is satisfying all these constraints is this one. That is, it will be something like a polygon like this. So this is the region which is actually satisfying all these constraints, and this is our feasible region. Okay, so to give you a better picture, I can show you a better graph. So the actual graph will look like this. Okay, so this shaded portion is our feasible region. This is our feasible region. Now, just like how I have told before, you have to plot the points. So you can name it as A, B, C and D. These are the points, and the closed figure will contain the feasible region. Okay, so point A, it is already given. This is 0, 2, which is known to us. This is A. Then point D, this will be C. The point D is 4, 2. These are the coordinates 4, 2, because it is like this. It is clearly known. Again, point C. Point C, you can plot it. Okay, you can find out by plotting that point. You can get the value of C as 4, 6. 4, 6. As you just join this line, you can get it as 4, 6. Then point B. If you check for point B, you can get to know that this is 0.7, 3.5. If it is a graph paper, it will be very clear to you, because in graph paper it is very easy to find out the points. Okay, but if you are doing it in a plain paper, just like how I have done, then you have to be very precise with the scale. Here I have taken 1 unit is equal to 1 centimeter. So between each between each unit you have 10 points. So like that you can understand that this is 0.7, 3.5. Now the rest of the procedure is simple and similar. What you need to do is you need to find the Z value for each and every point, that is point A, B, C and D. Okay, so we will find out the Z value for each point, and then let's see what is the final answer. So Z of A. ZA is equal to our objective function for this particular problem is Z is equal to 3A plus 5B, right? So for Z is equal to Z at point A, the coordinate is 0, 2. So you can put 3 into 0 plus 5 into 2 and you will get the answer as 10. Then Z for B, that is 0.7 and 3.5. So Z for B is 3 into 0.7 plus 3 into 0.7 plus 5 into 3.5. So you will get the answer as 19.6. ZC is 3 into 4 plus 5 into 6. The answer is 42. And ZD is 3 into 4 plus 5 into 2, which is equal to 22. Okay, so these are the 4 points. Now what is the question? Question is minimize Z equal to 3A plus 5B. So this is a minimization problem. So you have to find the minimum value of Z. So according to the answer, the minimum value of Z is at point A. So you can write optimum solution is at point A, and Z of A is equal to 10 and A is equal to 0, B is equal to 2. So this is your optimum solution. I hope this is very clear to you. The only thing is here, when there are more than 2 constraints coming up, you will have to plot each and every point. You will have to draw the constraints, and wherever they are converging, if they are not converging at point, try extending the lines till they converge, okay, or till they intersect, and finally find out the feasible solution. And remaining procedure is all the same. According to the objective function, if it is a minimization problem, find the minimum value. If it is a maximization problem, then find the maximum value. That is it. Hope this is clear to all of you. Thank you, students.